Today I'm going to run through the basic steps used when performing an LBL calibration with Fusion 2. I'll outline the basic collection and processing features and highlight the improvements over Fusion 1. While the general process is similar to Fusion 1, the actual steps required by the user have been greatly reduced and simplified. Real-time network adjustment of the data as it's collected and during reprocessing being the biggest changes from the user's perspective. So let's begin. In the toolbox on the left, we can open the calibration tool, and on the left of that we have the options for real-time or reprocessing. The difference here is that with real-time we can collect the data as well as compute the results. Below, it gives us the option to perform 3 different types of calibration: baseline, box-in or slam. Baseline is the default option, so we'll leave it at that. The other options are outlined in other how-to videos. In the baseline calibration settings, we can rename the calibration file to make it easier to find later. Below this, we have the settings to control how Fusion 2 plans the data collection for us. We can set the minimum number of baselines we want for each compat, and the maximum baseline length we'd expect to be achievable due to the environmental conditions at the worksite. Then we can set the number of measurements we require for each baseline in order to meet our project procedures. On the right hand side of the chart, we have the tools for manual planning. If there are baselines we know from topographical analysis don't have line of sight, we can remove them here, preventing the system from wasting time trying to collect them. On the chart we can see graphically what Fusion 2 intends to collect, and it will try to calibrate any uncalibrated compats that have a location. By default, it will use any calibrated compats within range as references. Once we are happy the software is set to collect the data we need, we can click Continue to Calibration to bring up the calibration bar and the baseline calibration diagnostic window. We can click on the play button in the calibration bar to start the process, and we have nice clear graphics to show us what baseline it's collecting at that time. As soon as the first round of data comes in, the results table opens up and we can see the software begins to refine the start positions. The real benefit here is that if we see the positions change dramatically, we know there's a problem. These are highlighted in bold orange text. This means that unlike Fusion 1, we don't have to spend long periods of time collecting data, only to find out later that it isn't usable. This information is also shown graphically in the baseline calibration diagnostic window, if you prefer to look at it that way. Baselines are collected using the same simultaneous process as Fusion 1, but the logic and the way the missed ranges are handled has been improved, so you should see a reduction in collection times in difficult environments. On top of that, we can also collect sensor data seamlessly with Wideband 3. Wideband 3 allows data to be collected without the need for telemetry. For baseline calibrations, this allows us to retrieve real-time sound speed from each enabled device much more efficiently and at higher rates than we could with Fusion 1. If you've been collecting from multiple sound speed sources during the collection, you can change the active source so as to use the closest historical data set or swap to a profile at any time. The workflow has changed slightly in how we dictate whether we are performing a relative, absolute or extend array calibration, and we no longer need to specify this during the planning stages. This is now controlled by what we have set in the locations table, which can be changed at any time during the process. All references now have an error ellipse associated with them, which controls their weighting in the least squares adjustment during calibration and tracking. This makes it much easier to use a mix of methods and enables us to make the most of the information we may have about any existing array compats. This could include previously installed assets that we might want to tie the new array into. If we mouse over a baseline on the chart, we can see the SDs, and we can right click on the baseline to view the ranges as histograms. Data can be manually excluded by dragging the sides of the graphs as we did with Fusion 1, but this is best left to the auto rejection algorithms. Or we can look at all the baseline residuals in one go, making it easier to QC the simultaneous ranging in real time. The process bar at the top shows our progress and when data collection is completed. We can now QC the data by changing between relative and absolute, and 2D and 3D, as we would have before, but now we can do this in real time without the need to keep reloading the data. This reduces the chances of making mistakes and brings the time down from hours to minutes. This is great as the vessel's normally waiting for you to give the thumbs up before moving on to its next part of the work scope. Once we're happy with the results, we can click Apply Calibration. This sets the compacts to calibrated, saves a PDF report, and we're ready to get to work. So that's that. As you can see, things have changed a lot, but the workflow is similar enough that it doesn't need big changes to existing procedures, easing the transition to Fusion 2. Thanks for watching. If you have any questions, please contact the survey support group at support@sonardyne.com. For more detailed information on this or on any of our other Sonardyne products, please check out the training pages on our website. Happy tracking and goodbye!